Hello everyone, my name is Neha. I'm a software developer engineer with Apple. Um, Today we are going to talk about unlocking dynamic front-end development through JSON schema. So today we are going to cover these topics. We'll start spend some time giving a brief overview on Jupyter notebooks. We'll understand what are Jupyter kernel configurations. We'll go over how it is like building a kernel configuration experience in the traditional approach. We'll go over with JSON schema and then how it is different to building a kernel configuration experience using JSON schema. Later, we'll dive deep on technical architecture and then we'll explain our future work on this area. So, Jupyter Notebooks. Jupyter, it's an open source ecosystem. The screenshot on the right side is of Jupyter Lab, which is essentially an in-browser IDE, and which provides a rich user experience for various data activities. Jupyter is language agnostic. Here, users can create notebooks and use different compute environments like Spark, Scala to run their notebooks. So Jupyter allows data engineers to prototype their code based on their need, as well as providing analysts and scientists with the ability to write queries, code, and experiment by launching interactive environments in Jupyter Lab. Now, um, Jupyter kernel configurations. These configurations are kernel specifications where users can define the resource properties and security properties, or if a user wants to access some data on from S3 or any data storage, they can add those details in configurations and their runtimes. If users are running kernels remote or local, based on their runtime, they can they can add those configurations in Jupyter kernel configurations, and then launch the kernels using that configuration. So configuration is basically a bundle of everything which a kernel uses when the users are firing queries. We'll go over into some of the details around these configurations later in the demo. Now, Jupyter also provides support for custom configurations. So there are some vanilla configurations provided by user, which you can use, but there are some custom configurations around each programming language. So Jupyter has support where enterprises or any other user who wants to add like a support for different programming language or for different environment or different runtime, or different data access properties, they can add them and make it uh, compatible for their use case and then use it. So so if we look at the kernel configuration scope, it's really huge in the worlds of Jupyter, because it has a different personas which users are using Jupyter for, and the horizon is pretty high here, where there is a customization. There are different types of configuration. So so let's see how it is like building the configuration experience in the traditional approach. So as you see in the diagram here, UI development is doing its development independently, and the backend engineer is doing its development independently. Now, during runtime, if you have to make a change, a lot of things are needed. Like it's a two-step process without JSON schema. So every time a new change is done on the back end, it needs the coordination in the UI side, or vice versa. So and and then there has to be some validation, and then if there is some error, then the UI engineer has to talk to backend engineer around the contract and the validation errors and whatnot. So it's a time consuming process where it needs more coordination between UI engineer and backend engineer, and it makes the overall development very slow. And it's error prone as well. That every time there is some mismatch in the data contract or the data handling or validation or testing, it needs much more closer coordination between both these two. Now let's see what are the limitations as we have seen in the previous slide. So there's a tight coupling of UI and the logic, because UI needs to be aware of a lot of things, which backend does. There's a very tight coupling, and the UI has to define the logic and the rendering the form with some business logic. um, and then there are some scalability challenges, in the sense the time it takes, and then given that there's a lot of logic on the UI side, they have to be aware of all the business logic, and it makes it more less scalable, and there's no reusability. So UI is building its own side, and then backend is doing its own side, and every time a new form has to be added, you can't really use any of those components. You have to really build a new component at the UI side every time there's a new screen required. And this is there's a lack of data driven approach here. It's more of a business logic where every both parties are handling things differently. And as we know, like, there's a tight coupling, there's a poor separation of concern between these two logics, and less flexibility, because every time a change is made on backend, the UI needs to be changed, and the vice versa. So it makes things very slow and less flexible. And then once you have a lot of UI states, different and complex states, it becomes more and more complex to handle all those business logic at the UI layer. So let's talk about JSON schema, as I think many of you already know. So I just have this the screenshot on the right side, which is a JSON schema. So JSON schema essentially is a structure or specification which describes the JSON data. It can validate the data for you. It can describe the data structure for you. It has a different properties where you can define, okay, what's the type, how does it look like, how, let's say it's a string, you can say a pattern matching, or you can add a different type of validation logic. And then it is mostly used in the API contracts between different systems. So JSON schema is heavily used in API contracts. But let's see how it looks like if we have to build a UI experience using JSON schema. So if you have a JSON schema being shared between the backend and the UI, um, then both are really relying on just the JSON schema. So there's a shared JSON schema, and then which the both parties are using. Now, the benefit here is there's no manual updates. And so since the JSON schema can do a lot of things for you, you are adding your validation logic, your business logic, how the form should be rendered. So everything is kind of inside the JSON schema, where UI is just using the schema and rendering it. So there's no business logic within the UI, and it's loosely coupled from UI. So it's less error prone. It requires near to zero coordination, as it is data driven, that both are relying on the JSON schema. So, and it makes things very fast, and it's flexible, it's consistent. Now let me give a quick demo of how we have used it in Jupyter at Apple. So, oh, sorry. So if I play this one, see. Hmm. Okay. So this is a form which we have. So this is the Jupyter UI screen, and we have added an extension, Jupyter kernel configurations. And here on the left side, you see there are list of kernel configurations. So this says that this is the Scala configuration, this is Python, and then this is how it looks like to building a UI experience with JSON schema. So here the form is rendered using the schema, and then the schema, if you see, like it says, the required properties, so everything is driven from the schema. We'll take a look at the JSON schema, but let's see how it looks uh, in the UI. So user provides a name and user chooses a kernel type, and then based on the kernel type, right? It has a different, it pops up a different set of properties in the UI. So if a user has selected Python, it shows these properties, and then it says that, this is a required field, and it marks them accordingly. And if a user chooses a different type here, it renders the form with the different set of properties defined for this specific kernel type. And it also has, say, the full preset. And then, based on the previous selection, it renders the form accordingly on the next one. So it has all the required node properties, the pattern matching, and all set of validation rules are embedded in the JSON schema, and then UI just using that schema to just render the form. We'll deep dive into the technical architecture of how UI is rendering the form. Um, but for this demo, you can see that we have a lot of properties which we are setting here, and there is a support of custom properties as well, which it also validates whether this should be a valid JSON here. Um, and there are some the preset values for, let's say, secrets and your compute, and and it'll ask users to create the kernel spec. So uh, yeah, let's deep dive into what are the benefits of this approach. So if you look at the technical architecture, we have the backend and the front end. And the backend is having a JSON schema provider API. So every time UI has to render a form, it asks the backend, okay, give me the JSON schema. And it's very interesting here is that we don't have a static JSON schema. Rather, the backend is constructing the JSON schema on the fly by using user information, other type of information, and the base JSON schema. So based on user access, for each user, it's creating dynamically a JSON schema, and then the provider, the front end uses that JSON schema, and it has its own parser to parse the JSON schema and just render that. So all the validation rules. And sending back the data from UI to backend is also in the form of JSON schema. So it's JSON schema everywhere. Like we have base JSON schema, we modify it on the fly for the use for each request, and then send it to front end, and the front end just uses the JSON schema and to render the form and get the data from the user and then send it back according to the schema. So yeah, we have seen like there are different components here. The backend has the JSON schema provider, the front end has the parser and the dynamic form rendering. So the schema provider is dynamically generating the schema for each user. It's data driven. It has a lot of customizable rules. as you have seen in the demo, that based on use selection of different set of fields on the UI, it decides what to render next. And it has a data validation, and it's kind of a real time updates, because anything changes on the user level, let's say access level, everything is just dynamically generated and real time updated on user's screen. So this is the base schema. I mean, this is just a screenshot of how we have defined the base schema. Is we have the definitions. We have multiple definitions for storage, catalogs, tables. We have different kernel types. We have different Spark properties. So everything is embedded in the base schema, and we have different rules on those schema and what to show and when. Now, in future, we are trying to open source this work. This is right now within our organization, but we are talking with the Jupyter community to open source the work which we have done, and so that the community can leverage. So we are inviting collaborators. So if you're interested into any type of contribution on Jupyter, JSON schema, this is the meeting link, and you can go ahead and look at the schedule. There are quite a few meetings which happens every week. So yeah, feel free to join, or yeah, and do the contribution. Yeah, and that's all from me. Thank you.